Part C, no equations in y equals mx plus b. This is probably the hardest part of substitution when none of your equations are given to you as y equals or sometimes even x equals. We can work with an x equals as well. So substitution is the best choice when we are solving for a system of equations if one of the equations is in slope-intercept form or y equals mx plus b form. If they're not, if both of the equations are in standard form or some other variation, then we want to choose one of the equations to change into that slope y-intercept form or even to isolate for the x in some cases. We're going to take a look at a few examples to see how we can do this, and we're going to explore some tips and tricks on how to make this more efficient. What we want to do is we want to solve for the system equations. So we want to find out where these two straight lines intersect. We're still going to do our substitute, solve, check, conclude, but we're going to add another step to the beginning. And our step to the beginning will be to isolate for one of our variables. We're still going to go ahead and label our first equation number 1 and our second equation number 2. Step number 1 in this problem says to solve equation 2 for y. You could also solve for number 1 for y. What we want to do is we want to isolate a variable from one of our equations. I've just chosen equation 2, but you could easily do it for equation 1 because both of these coefficients in front of your y is a 1, or there's no number in front of your y, which makes it easy for us to isolate for either of these y's in either of these equations because there's nothing for us then to have to go and divide by. If we're looking at equation number 2 is 2x plus y equals 7, and we want to isolate for y. So that's what we're doing here. We're isolating y from equation 2. Okay. What we want to do is we want to get y all by itself, and we do that by taking any other term that's on that same side and getting rid of it. So we're moving it to the other side of our equal sign by using our opposite operations. Right now, our 2x is a positive value. So the opposite of adding 2x is subtracting 2x from both sides. 2x take away 2x is 0. So we're left with y on the left-hand side. And you can either choose to write your 7 first or your negative 2x. I'm going to go ahead and write my negative 2x first because then it's in that form y equals mx plus b. But you could write it as y equals b plus mx. They still mean the same thing. Okay. So now that I've isolated my letter, so one of my variables from one of my equations, now I need to do my substitute, solve, and so on. So this is my new equation 2, for example. Okay, so what we're going to do is we're going to go ahead and we're going to substitute this value that I found for y, which was negative 2x plus 7, and I'm going to put it into equation number 1. And I'm putting it into equation number 1 because I've rearranged equation number 2. So this has to go in to this y right here. So that's substituting for y in equation number 1, and I'm going to solve for my x. So now there's my substitute solve again. I know how to do that. I've done that in part A and I did it in part B. So after I've done that isolate, so that was that first step that I have to do that's new for part C, then I follow the same steps that I did for before. So I'm going to take my equation number 1. I'm going to start by writing my 4x plus, when I get to y, I'm going to go ahead and put that in a bracket again. So 2x plus 7, close my bracket, equals 5. Why do I put this in a bracket? Well, just in case there happens to be a coefficient in front of this y, then I know that I can use my distributive property. If there isn't, or if this was a negative value, then I would have to do that as well. You can pretend that there is an imaginary number 1 in front of here and do the distributive property if you want to. So multiplying both of those by 1s, but knowing that when you multiply by 1, it doesn't change the value. So it just becomes 4x minus 2x plus 7 equals 5. I'm going to collect my like terms. 4x minus 2x is 2x. 2x plus 7 equals 5. Now I want to solve for my x by getting rid of that coefficient term, the constant term first. So I'm getting rid of the plus 7. The opposite of adding 7 is subtracting 7 from both sides. So starting with 2x, 7 take away 7 is 0, so it's gone from the left-hand side, and that's equal to 5 take away 7. Continuing over here, I have 2x is equal to 5 minus 7 is negative 2. And now I want to get rid of my coefficient now. The opposite of multiplying by 2 is dividing 2. And I have to divide both sides by 2. 2 divided by 2 is 1, or 1x. And negative 2 divided by 2. X is equal to negative 2 divided by 2 is negative 1. Now that I have a value for x, now I need to take this value that I found for x, which is negative 1, and I want to put it back into equation 2. Now I can either choose to put it into my original equation 2, or I can put it into this isolated version of number 2. I'm going to go ahead and put it into this one instead, because then I don't have to rearrange anything. I don't have to move anything over. So I like to put my value for x back into that equation that I rearranged in step number 1. It just makes it a little bit quicker and a little bit more efficient to solve. So I'm starting with my equation y. Y equals negative 2. When I get to my x, I'm putting negative 1 in a bracket because I have to remember to multiply those two, and then plus 7. So now I solve for y. So substitute again, and then I'm finding or solving for y. Right? Anytime you see the word find, it also means to solve. And I do that by doing order of operations. Negative 2 times 1 is positive 2, and positive 2 plus 7 is 9. Now that I have a value for x and for y, I can do my left side, right side check. Because I put my x into my equation 2, I'm going to do my left side, right side check for equation number 1. So my left side, right side check, I'm going to start by drawing my t-chart, left side, right side. The left side of my equation for equation number 1 is 4x plus y. The right side is 5. My value for x is negative 1. My value for y is 9. 4 times negative 1 is negative 4. And negative 4 plus 9 is positive 5. So now that I've checked, now I can write my conclusion. The left side equals the right side. That's what I like to see. Therefore, the point of intersection is the coordinate where the x value is negative 1 and the y value is positive 9. Let's do a couple more examples. Example number 8. Start by labeling your equations, equation number 1 and equation number 2. So I want to find out where these two straight lines intersect on a Cartesian plane. I want to isolate for one of these variables. So I take a look at my equations. Equation number 1, I have a 5 in front of my x, so I don't want to get x by itself. But I do have a 1 in front of this y, so this is a good thing for me to solve for. If I take a look at equation 2, both of my x and my y's have a coefficient in them that's not 1. So I'm going to isolate y from equation number 1. So I want to get y all by itself. So I'm starting with 5x minus y equals negative 5. Because my y is negative on the left-hand side, I'm going to make it positive by putting it to the right-hand side. So instead of moving my x term, I'm going to move my y term so that it becomes a positive value. So when you are solving for one of your x or your y's, you want to make sure that it's a positive x or a positive y equals an expression. So I'm going to add y to both sides because that's the opposite of subtracting y. So I start with 5x. Negative y plus y is 0, and that's equal to negative 5 plus y. I could have put my y in front of my negative 5. It wouldn't have made a difference. Now I want to get rid of this constant term that's on the same side as my variable y. So instead of subtracting 5, I want to add 5 to both sides. So I have 5x plus 5 is equal to negative 5 plus 5 is 0, so just y on that right-hand side. I know that it's backwards. I know that you might be used to seeing y equals mx plus b, but mx plus b equals y means exactly the same thing. Okay? So now we're going to, now that I've isolated, so that's that first step now, isolate. Now I do my substitute, solve, check, conclude. Because I isolated my variable from equation number 1, I'm going to substitute 1, so this rearranged equation number 1, into equation number 2. I'm going to start by writing my equation number 2, 3x minus 6. When I get to the y, I write a bracket, and I'm putting this expression in here. So this is my expression for y. That is going right here into this y. So it becomes 5x plus 5, close my bracket, equals 24. Now that I've substituted my y value into my second equation, so that I just have one variable, now I can solve for x. And the first thing that I want to do is do the distributive property so that I can get rid of these brackets in this expression. I'm starting with 3x. I'm multiplying my negative 6 by my 5x. Negative 6 times 5 is negative 30, and then I tack on my x. And then I'm multiplying my negative 6 by 5 again. Negative 6 times 5 is negative 30, and that's equal to 24. Collect your like terms. 3x take away 30x is negative 27x. That's equal to negative 30 equals 24. From here, you want to isolate for x. So we first get rid of that constant term. The opposite of subtracting 30 is adding 30 to both sides. So negative 27x. Negative 30 plus 30 is 0. Those two disappear. Then I'm left with 24 plus 30. Keep going. I have negative 27x equals 24 plus 30 is 54. From here, I want to get rid of the coefficient in front of my x. The opposite of multiplying by negative 27 is adding by negative 27. Or sorry, dividing by negative 27. Negative 27 divided by negative 27 is x, or 1x. So because negative 27 divided by negative 27 is 1, and I have 54 divided by negative 27. So x is equal to 2, negative 2, because a positive divided by a negative is a negative. Now that I have a value for x, I'm going to take this value of x and I'm going to substitute it back into that equation that I rearranged for y. So I'm taking this negative 2 and I'm putting it into this x right there. So I'm subbing x equals negative 2 into, this was equation number 1 that I just rearranged. So I can either put y equals first or 5x plus 5 first. I'm going to go ahead and put y equals first. So y equals 5x plus 5. So instead of my x, I'm putting negative 2 in its place. And I'm solving for y by following order of operations. Y equals 5 times negative 2 is negative 10, and negative 10 plus 5 is negative 5. Now that I have a value for x and y, I have to do my left side, right side check. And I'm going to check equation number 2, because the last equation that I substituted into was 1, so now I check 2. So I'm doing my left side, right side check. The left side of my equation is 3x minus 6y. The right side of my equation is 24. My value for x was negative 2. My value for 6 was negative 5. 3 times negative 6 is, 3 times negative 2 is negative 6. And negative 6 times negative 5 is positive 30. And negative 6 plus 30 is 24. The left side equals the right side, so now I'm ready to write my conclusion. So left side equals the right side, therefore, the point of intersection, or POI, is the coordinate where my x value is negative 2 and my y value is negative 5. Let's do one more example. Start by numbering your equations, 1 and 2. Take a look at the coefficients in front of your variables. Look for the one that doesn't have a number. That's your y. So I'm going to isolate y for equation number 1. That's step number 1 in my equation. So I'm starting with 2x plus y is equal to negative 8, and I want to get y all by itself. Because my y is a positive value on the left-hand side, I'm going to move my 2x over to the right-hand side. So I'm going to take my 2x. Right now it's a positive 2x, so the opposite of adding 2x is subtracting 2x. 2x take away 2x is 0, so I'm left with y. And then I have negative x take away 2x. You could put your negative 2x first like we did in that other example, or you can write it backwards. It means the same thing. So now that I've isolated for y, I'm going to take this value for y that I just figured out right here, and I want to substitute it into the y in for my other equation. So I'm taking this expression and I'm putting it into the y in equation number 2. So I'm subbing my new equation 1 into equation number 2. I start by writing my equation number 2, 3x minus 5. When I get to y, I put a set of brackets. Inside of that bracket, I'm writing the expression for y that I solved for in that first step. So negative 8 minus 2x. Close that bracket, and that's equal to negative 25. Now I want to solve for the only letter I have left, which is x. And I do that by first doing the distributive property. So I'm taking my negative 5 and I'm multiplying it by everything inside of this bracket. So start with your 3x. Negative 5 times negative 8 is positive 40. Negative 5 times negative 2 is positive 10, and then tack on that x at the end. and that's equal to negative 25. Collect your like terms. 3x plus 10x is 13x. Plus 40 equals negative 25. From here, you want to get your variable x all by itself. So we start by moving over the constant term. The opposite of negative or positive 40 is negative 40, or subtracting 40 from both sides. So 13x. 40 take away 40 is 0, so it's gone from the left-hand side. Then I have negative 25 take away 40. At this point, what you want to do is you want to then subtract your negative 25, or negative 25 subtract 40. So that gives you negative 65. So I have 13x is equal to negative 65. At this point, we want to get rid of the coefficient. The opposite of multiplying by 13 is dividing by 13. 13 divided by 13 is 1, so I have 1x, and negative 65 divided by 13 is negative 5. I can show that step at this point, so negative 65 divided by 13, x equals negative 5. Now that I have a value for x, I'm going to take this number, this negative 5, and I'm going to put it into my x in that equation that I first rearranged. So I'm substituting x equals negative 5 into equation number 1. So that is the same equation here, but I just rearranged it. I'm going to start with my y. Y equals negative 8 minus 2. When I get to the x, I'm putting negative 5 in a set of brackets. Now I solve for y. And I do that using order of operations. Make sure that you do your multiplication before you do your subtraction. So negative 8. Negative 2 times negative 5 is positive 10. And negative 8 plus 10 is positive 2. Now that I have a value for both x and y, I need to do my left side, right side check. And I'm going to do that for equation number 2. So I'm going to check equation number 2. So you'll notice 1, 2, 1, 2. So separate your equation into the left side and the right side. The left side of your equation is 3x minus 5y. The right side of your equation is negative 25. Substitute the value in for x, which is negative 5. Substitute the value in for y, which is positive 2. 3 times negative 5 is negative 15. Negative 5 times 2 is negative 10. And negative 15 take away 10 is negative 25. Once you have determined that the left side equals the right side, it's time to write that conclusion. The left side equals the right side, therefore, the point of intersection is the coordinate where the x value is negative 5 and the y value is positive 2. So the only addition to part C when we're looking at substitution is that isolating part at the very beginning. So isolate, substitute, solve, check, conclude. I hope that helps you. If you have any questions, please reach out. Sign up for a virtual help session or send me an email, and I will see you in the next lesson.